Hello again, it's Dr. Maxwell, and we are talking about confidence intervals. So, just a little summary of what we talked about before. Here's the idea. You have some sort of research question that you're trying to answer about some population, and you want to estimate an unknown population mean, mu. So, you get some data and you calculate the sample mean, and that is the point estimate. So when you're asked what is the point estimate, it's the sample mean. Now, we mentioned how if you went out and got another sample from the same population of the same size, of course you're not going to get the same sample mean. So there is some uncertainty associated with this point estimate. And the standard error helps us quantify the point, this uncertainty. So what is the standard error? It's the sample standard deviation divided by the square root of n, where n is the number of observations or measurements or data points if you prefer. And then what we do is we calculate an error margin. And you see this XX% here. Well, that depends. That's something you should have decided before you start working with your data. What kind of confidence level are you going to use? We talked about 95% being a common one. So that will be given to you in the problem. In the real world, you will have to decide what you're going to use. And whatever percentage this is, that determines this value of Z star. That corresponds to your confidence level. And then finally, you put it all together and create this interval that's centered around the mean. So what we do is we have our mean. If that sits on a number line here, then we're adding this XX% error margin to the mean, and then we are also subtracting it. And this gives us an interval around the sample mean that will be centered at the sample mean. So this provides what we call an interval of plausible values for the unknown population mean mu. Remember, that is unknown or we wouldn't be doing this. Okay, so this is very important. How do we interpret a confidence interval? When you go to report your findings, you're going to say something that sounds a little awkward, but we will say, we are 95% confident that the true population mean lies in this interval of values. And you might phrase this part a little different, like lies between this number and that number. But this is the important thing. You say we are 95% confident that the true population mean is in our interval. Now, we can try to understand this a little bit more. What does it mean? What does this 95% confident mean? And I think this is a pretty good explanation. So if you take 100 random samples of the same size, so N is the same, from the same population, and you calculate all the point estimates, you're going to have all these sample means. You will have 100 of them, and they're all going to be a little different. It'd be unusual if you got some that were exactly the same. Now for each of these, you create a confidence interval. So you're going to create 100 95% confidence intervals. I like to abbreviate that CI. So what does this 95% mean? It means that 95% of these 100 confidence intervals would actually contain the true population parameter. So that's how we interpret that 95%. It's not a probability. This comes from some statistical theory, and it tells us that if you repeat this over and over again, in theory, 95% of these intervals contain the true population mean, and that means 5% do not contain the mean. So there is always a chance that your confidence interval did not actually capture the true population mean. Okay, so now we're just going to do some practice. Okay, our first problem says we surveyed 130 people. So I see that that's going to be N. And my mean and standard deviation, my mean is 32. My standard deviation is 9. So let's write those up here. My mean is 32 years. Standard deviation S equals 9. So this is a survey of 130 people employed by the state of Colorado, and their ages were found, the mean of their ages was, what are we talking about? Ages in years. The average age was 32 with a standard deviation 9. And we're asked to form a 95% confidence interval for the mean age of state Colorado employees. Okay, so we want a 90% confidence interval. So what is Z star? You go to your handy dandy table here. This is the column we're interested in. This will equal 1.645. Okay, so this is how I like to do it. I like to calculate my standard error. That's S over the square root of N. So S was 9 divided by the square root of 130. Now, I'm going to round this to 0.79 because my final answer is going to be rounded, it says, to the nearest integer. So that's my standard error. Now I'm going to calculate my 90% error margin. This will be Z star times the standard error. And if we do this and round, I get 1.30. So that is this number that I add to the mean and subtract from the mean. Okay, so now I'm ready to create my confidence interval. I'm going to take the mean and subtract 1.30, comma, and then the mean plus 1.30. And then I'll write up my final answer like this. 90% confidence interval is going to be 31 years to 33 years. So we are 90% confident that the true mean age of the state Colorado employees is between 31 and 33 years. Done. Hopefully this gets a little less scary every time we do it. Now, in this problem, what are we talking about? A study about poverty level by county. So in this study, the number of residents living below the poverty level was measured for a random sample of 40 counties. And it says the sample mean, the number of residents who were found to be living below the poverty level, the average was 316. That's how many were living below the poverty level. And the standard deviation was 145. Now this problem is a little confusing because of this part here. That's why I put the words in bold that I did. These counties were chosen because they had less than 500 residents. Okay, so we have N, we have our mean, we have our standard deviation. We need to figure out what Z star is. Well, we want a 98% confidence interval. If we go back and look at our table, that's not in the table. It's going to be somewhere between 95 and 99, but I'm going to show you how we can figure out what Z star is for a 98% confidence interval. For that, we have to go back to the standard normal distribution. And this also sort of gives you another idea of what's really going on here. So this area between Z star and negative Z star is 0.98. Now, what are these two areas over here? That is what I need to figure out. Well, what is 1 minus 0.98? That is 0.02. So this area, maybe I'll try to shade this in purple. This little tail over here is the same size as this little tail over here by symmetry. The two purples together, they have to add up to 0.02. So this is 0.02 divided by 2, which is 0.01, and this is 0.01. Now, why did I do that? Well, because I want to look up on the table and we want to find Z such that the area to the left is what? Well, I'm going to try to find this Z. What is the area to the left of this Z? It would be 0.98 plus 0.01, making it 0.99. That's the total area to the left of Z star. So that's my Z star. And let's see, I think I have a table here for us to look at. It's not a complete table, but what are we looking for? We want to get as close as we can in the area section to 0.99. So we're looking in the areas, try to find 0.99 and get as close as you can. So we're just going to pick one of these two numbers. Which one do you think is closer? And we could consider this one also. I think that one in the middle is the closest we can get. This tells me the z-value is 2.3 with the second digit of 3. So now I can go back to my problem and I know what z star is. Okay, let's do the other work we need to do. What is my standard error? That's s over the square root of n. That will be 145 divided by the square root of 40, which is 22.9 if we round. And what is our 98% error margin? That's z star times my standard error. So this will be 2.33 times 22.9. And that, if we do that calculation, is 53.36. Which I'm going to go ahead and round to 53.4 because I see again I'm looking for the nearest integer. Okay, now we're ready to create the confidence interval. I'm going to take my mean, which is 316. I'm subtracting 53.4 and I'm adding 53.4. And so finally, I can write my 95% confidence interval as 263, 369. So what this tells me, I am 98% confident that the true number of average number of people living below the poverty level in these counties is between 263 and 369 people. All right, let's do one more and then we're going to work some homework problems. Let's see, what is this asking? In a period of 2 weeks, the temperatures of a large number of malaria fever patients is taken every hour. And a 95% confidence interval is calculated for the mean of all patients in the study. So they did this for 2 weeks and they calculated 336 confidence intervals. So we have 336 of these, and they're all the same confidence level, the same number of people. So here's the question. Of these 336 confidence intervals, how many approximately, or in theory, will actually contain the true population mean? Well, this goes back to what I said way at the beginning. In theory, XX% of these intervals would contain the true population parameter. So, in theory, 97% of the 336 intervals, intervals contain the true mean. So how do I figure out what that number is? Well, 97% of 336 would be 0.97 times 336. If we round to the closest whole number, that tells me that there are 326 of them. That's what the question is asking for. Okay, we'll stop here. And I'm going to right away work some homework problems and post them together with this lecture. So this is the end of part 1.